Hello everyone, this is Bharati. I'm currently pursuing third year in Electronics and Communication Engineering at Chennai Institute of Technology. Today, I'll be presenting my project under the title AI-powered price prediction system for crops under the theme Toa Software Co. Limited, Study Japan, with topic Smart Market for Smart Produce. The problem statement I identified today is in both Japan and India, fresh produce markets face similar challenges. Unpredictable weather events like cyclones or typhoons or monsoons, sudden seasonal demand spikes due to festivals or school lunches, and transport delays due to logistics and cold storage issues. These problems lead to farmers struggling with uncertain incomes and food waste, and retailers facing difficulty in planning, procurement, and pricing. Policymakers lacking real time data to stabilize markets. So, the solution for this problem is an AI-powered web application that predicts fruit and vegetable prices. It combines the historical price data, weather patterns, and seasonal trends to produce daily and weekly price forecast, demand insights, actionable alerts like price will increase or decrease by next week, or it can be stored longer, or etc. And the system is designed for both Japan's and India's fragile, fragmental markets. So the objective of this project is very clear to train an AI model on 10 key crops like which are common to Japan and India like daikon, cabbage, potato, apple, and mikan, achieve over 75% of prediction accuracy using hybrid machine learning models, deliver farmer-friendly dashboards in multiple languages to minimize prediction errors with the target made below 25%. And the success rate of this project would be the farmer's income stability improving by 50 to 20%, retailers reduced wastage by 10 to 12%, real-time updates every 24 hours. The system architecture of this project includes 6 layers, and the first being the data sources, where the data sets or data are imported from several sources like databases, APIs, and IoT sensors. And the second layer is a processing layer, where the extracted data is processed, cleaned, and outlier detection and anomaly detection happens. And the third layer is the machine learning model development, where we use different types of models to predict uh, the current series data about the time series data about the price prediction, etc. And the later part includes the backend API, where the Firebase functions and Node.js is included. In the Firebase function, it is event driven. And the fourth is the front end. The front end of the project is the dashboard, and then it reaches the end users. The tech stack of this project includes for front-end, React.js, Tailwind CSS, Recharts. For backend, Node.js, Firebase functions, and Firestore databases is used. For tools, GitHub, Firebase for hosting, CI/CD for pipelining, and for databases, as I said, Firebase, Firestore for real-time synchronization. And the model AI/ML model used here are Scikit-learn for baseline models and TensorFlow for deep learning, Prophet model for time series forecasting. And the data sources are the sensor data or the APIs or the databases included, and the sources are Open Weather Map, Government Agri API, Japan MAFF, India AgMarkNet, seasonal crop calendars for predicting the seasonal issues, and optional IoT sensor inputs like temperature, humidity, and soil is also included in this project, which is not mentioned here. And the deployment, uh, the Firebase hosting plus Cloud Run functions. Cloud Run functions of Google Cloud Platform is used. The workflow of this project includes the data collection from the weather, pricing and transport feeds, cleaning and feature engineering to capture seasonal and festival issues. Prediction engine runs hybrid machine learning models. API layer delivers results to dashboards. User received price trends, demand insights, decision supports, and alerts. The data flow cycle in this web application includes the user interacts with the front end, which then leads to the Firebase, and then the backend API, which processes the request, executes the Firebase functions, and then the AI models analyzes the data with AI, and which leads to the Firebase data store, which stores and retrieves data, and then which again leads to the external APIs, which integrates with the external data sources. My solution for this project is feasible because it's built on existing APIs and scalable cloud systems. And the innovation of these projects include hybrid AI models for higher accuracy, scenario simulators to predict price impact of events like cyclones or typhoons, localization with dashboards like local languages, Japanese, Hindi, and Tamil, etc. Right now, I'm incorporating Japanese, Hindi, and Tamil, except English, and the other languages would be imported later. The impact of this project for India and Japan are the farmers in Japan optimize production and align with supermarkets in India, which reduces the food waste, avoids distress sales. For retailers, smarter procurement and pricing, less overstocking and spoilage. For consumers, more stable prices, better food availability. For policymakers, real time visibility on food supply and pricing trends helps design subsidy and buffer stock private policies. To summarize this video, my solution is scalable, AI driven, that stabilizes markets in both Japan and India. It uniquely combines hybrid AI models, scenario forecast, and multi language farmer tools. Our vision is simple yet powerful: smarter prediction today, sustainable food systems tomorrow. And thank you for the opportunity. It would be really great if I'm invited to Japan because I love the Japanese culture and the technology which are going on Japan. Thank you.